Welcome to part 2 of the Getting Started with LTspice tutorial. We are going to build a half-wave rectifier and run a simulation called a Transient Analysis. Unlike the DC operating point, we will see the waveform, perform some trace manipulation, and even do a little bit of math. A half-waveform rectifier consists of an AC source, a diode, and a load. So let's build that circuit. Place our diode. We're going to represent the load as a 1 kilo ohm resistor. Now, to place an AC signal source, we're going to drop down the same voltage source that we did in the last video. However, instead of adding just a DC value to it, we're going to right click, go to Advanced, change it to a sine, amplitude of 5 volts, and here you need to specify a frequency. So since we're doing a transient analysis, I'm going to set this to 1 kilohertz because 1 kilohertz in the frequency domain correlates to 1 millisecond in the time domain. So in 3 milliseconds we will see 3 periods of the sine wave. Let's connect this up. Make this look a little bit better. Okay. Now we need to specify a model for this diode. We're going to choose the diode that SparkFun sells in the storefront. And what's awesome about LTspice is that on the diode, if you go to pick new diode, you'll see here hundreds of models from different manufacturers. So you've got a wide range of models that are already built in. So SparkFun sells the 1N4148. So we're going to choose that model. We're going to change this to 1K. Now to run a transient analysis, we're going to go to Simulate, Edit Simulation Command, and here it's going to pull up all the different types of simulations that we can do in LTspice. We're already on transient, and since we want to see 3 periods, we're going to choose a value of 3 milliseconds. So what this dot operator is doing is saying run the simulation as a transient for 3 milliseconds. So, I'm also going to add an output here so that it's just a little bit easier. We'll label that net as V out. Alright, and now we'll run it. So let's first see what our source is doing. And here it's exactly as we expected. We want to see a sine wave going from 5 to negative 5 volts. Now let's see what our output is doing. And it's exactly what you would expect from the name half-wave rectifier. So something interesting that's happening here is that there is a voltage difference between these two peaks, between V in and V out. So let's zoom in and see if we can't get a closer look, but it's still kind of difficult to see exactly how many. So let's do some math. So I'm going to cut V of V out out. I'm going to right click on the label for node 1, and I'm going to subtract V of V out. And now what we're getting here is about 650 millivolts, which is exactly what we would want to expect because there's going to be a diode drop of about 0.7 volts. So this simulation is just right in the ballpark of what we would expect to see. Now, since we're in the simulation, I want to show you guys a few things. One is that if you left click here, you can actually change the vertical axis. So let's say we want to look at this from 700 millivolts to 600, and that's just going to, increase that scale. And you can do the same thing on the horizontal axis as well. And if you ever want to see how many traces that you can put up in one waveform viewer, what you can do is go to Plot Settings, Visible Traces, and this is going to tell you what all of the possible traces you can add are. And now I forgot here that you can also check the current that's going through these devices. So why don't we do that? So to check the current, you actually just hover over the part itself, and you'll see this little red arrow pointing down, and you just click on that and it's going to give you the current. And since this is a single mesh, all of the currents should be the same. And they are. Alright.